Hello, am I audible?
Yes, Priyanka, you are audible.
Yes,
Okay, so good morning, everyone. Our team of Codebusters welcomes you all to our second webinar on machine learning. We at Codebusters are here to help you with all the necessary technical skills needed in a technologically driven environment where everyone is able to contribute towards a better world. Now, we are all aware of the pandemic situation going on. COVID 19 is not the first and it won't last. Hundreds of research teams around the world are combining their efforts to collect data and develop solutions. And guess what acts as a tool for them in this? It's machine learning. So, today we have our mentor, Mr. Gaurav Gahawar, to throw some light on the topic. He is the head of IT department in Navrashna University. Gaurav sir is pursuing his PhD from Navrashna University, Vadodara. His research work is stock prediction using ensemble learning approach. He did his MPhil from Global Open University, Nagaland, wherein his thesis is titled Online Data Management and Mining of Heterogeneous and Active Time Sequence. He did his master's in computer applications and bachelor's of science from Sardar Patel University, Vallabh Vidyanagar. We are truly obliged to have him here today. So now, without much further ado, we would like to welcome him and start with our today's session. Thank you, sir.
Thank you very much, Priyanka. Am I audible? Is it okay, everyone? One of you can confirm me.
yes, sir.
Yes, sir.
Yeah. So, first of all, I congratulate Priyanka, Darpan, Shell, and the entire team of Codebuster because you people are doing something which is very unique. This group is inviting lot many people from outside and conducting such sessions free of the cost. In fact, in the future, we have a plan to invite people from industry as well, so that they can share their experience. They can share their tricks on different things. So once again, congratulations to Darpan, Priyanka, and in future we will do lot many such events, such webinars, even some physical seminars as well. Now,
Thank you.
regarding regarding today's topic, machine learning. I mean, I'm sure most of you are from computer discipline. I can see many of my students. I can see few students who are not from Navrashna as well. So all of you have just heard this term machine learning, but no one has understood this machine learning well. The entire idea behind this 2 day webinar would be very simple to make you understand about machine learning, and second, how you can implement machine learning in a popular tool called Python. We are going to use Python only. So at the end of this 2 day session, 2 day webinar, you will get to know that on which type of problem you can apply machine learning and in which type of problem you cannot. Machine learning is not a final capsule, understand that. There are some specific set of problems where you can apply machine learning in the most efficient and optimized way. So before that, we need to understand that what does this machine learning is, and from here we are going to start this. This 2 day webinar is organized in such a way that the first year we will be trying to understand what is this machine learning, and in tomorrow's webinar we will try to implement one of the algorithm. The algorithm which I like the most is a support vector machine, and those who have done some work in the machine learning, they know the importance of support vector machine. This is an algorithm which is used by many of the researchers at highest level of the research. So we are going to implement that support vector machine on some data. I have already gone through, downloaded some data from, there is a website called Kaggle. Now this Kaggle contains lot many data sets. You can download data directly from the Kaggle data set, and you can apply that data set in your algorithm. You can train your algorithm, and later on, for any of the real world problem, you can always get the appropriate desired output. So I've already downloaded few data set from the Kaggle. If you want, you can note down Kaggle, Kaggle.com. Definitely tomorrow we will again refer this as well. But you can find that you have a data available there in the form of text data, in the form of images data, in the form of video, even video data. A lot of data is available there. In fact, um, to fully explore Kaggle, what I have done last year, I was teaching a course on artificial intelligence in CSE program. And what I've done, I've given them one activity, one assignment that they have to find out an Kaggle data set. They have to apply any popular machine learning algorithm, and then they have to implement it. So we, in fact, this semester as well, my third year students, they are going to study artificial intelligence, and uh, I am teaching that course artificial intelligence with one of my co-faculty, Miss Priya. So such activity will definitely there, and our main focus would be more on this machine learning and these things. Um, Ideally, this session would not have been required because in IT program in Navrashna, the students know that we have given them the specialization. So one of the specialization was machine learning, but somehow either I believe there were very less students for that option was not available. So, but if suppose that option would have been there, students had opted that, then this session would not have been required. But anyway, in today's world, if you talk about the computer, there are few things which are working like anything. You and to name them, one of them is from machine learning. um, I will use machine learning and deep learning together because they work with the similar type of the problem. There is something called IoT, Internet of Things, and many of you have already selected elected for the this IoT elective. So it is good that you are learning this new discipline. There is something called data science where you are going to apply this algorithm on the real world data, and then that is known as the data science. Cryptocurrency, these things are there, but largely speaking, your machine learning, deep learning, your IoT, data science, they are going to rule the world for next few years at least. And by the time you will pass out, definitely, if suppose you are specialized in any of this particular field, definitely your job prospect, your future is going to be good. So just now I'm sharing my screen, and one of you will confirm me as soon as you. Um, okay. Are you able to see PPT now?
Yes, sir.
Okay. So, uh, okay. So, today we are going to study machine learning, and this will be the agenda of the day. I am not going in detail of this because we are going to study each and everything one by one. So we'll start with the application only. Now, students to whom I'm teaching, they know that the way of learning any topic is that first of all we need to understand the need of that topic. So why we need to study machine learning? Why machine learning is so important in today's world? These are some examples mentioned here. Some companies, some giants of their own domain. Um, you will realize that how they have used the machine learning, of course, in connection with lot many other topics, because most of these applications, they are using cloud, they are using big data, and then they are applying machine learning techniques on the data you're gathering from that. But you will see that, for example, there is an uh, uh, toy called Barbie, and I'm sure most of the girls they already know what the Barbie is. This is a most premium type of doll available in the market. The owner of this Barbie is a Metal, the company name Metal. Now, normally, whenever you talk about the toy, there is only one way approach. There is only one way communication. So you are telling something to toy, you are operating on the toy. Toy is not responding. And even if toy is responding, it is not how the human likes it to be responded. For example, if suppose there is a toy, you press if any of the button, it will say hello. If you will say hello, in response, the toy will say hello. So, but that is not how the human operates. So, it's somewhere in 2016, I believe, Metal, they have applied artificial intelligence using machine learning in a new version of the Barbie called Hello Barbie. Now, what is this Hello Barbie? This Hello Barbie, whenever you buy this Hello Barbie, you need to configure this Hello Barbie with your local Wi-Fi network. And this Hello Barbie consists of around 8,000 different commands, different responses, different statements. Apart from this, it contains around 20 games for any child can play with the Barbie and Barbie will respond. No, this is only one part. And nowhere there is something called machine learning. But what it is doing, initially I have said you that you have to configure it with Wi-Fi. Now, why you need to configure it with Wi-Fi? Whatever interaction is happening between child and the Barbie, all this interaction is stored somewhere on the remote cloud. And then machine learning is applied on the data, and appropriately the Barbie will be given response. So if suppose today you have interacted something, that data is uploaded on the cloud. If suppose tomorrow you will interact the same thing, you will not get the same response from the Barbie, because now Barbie is more intelligent due to the machine learning algorithms applied on the cloud by the Metal. So this is how an intelligent Barbie works. In fact, for example, if suppose you are interacting with the Barbie and you ask the question, "What is your name?" If suppose it responds Barbie, then you will interact something else. What is the color of your frock? How old are you? And after some time, if suppose you ask you the same question, "What is your name?" So, what do you think? Whether Barbie will give the same answer? It may not give the same answer. Barbie can simply say, "I have told you that my name is Barbie." So, your Hello Barbie is a program which will not give response, a similar response for the same questions. Depending on the situation, depending on the interaction, it will give the result. So here is where the very simple looking toy is there, where machine learning is applied. Your Alexa, Cartona, they are the standard examples of machine learning. Lot many intelligence is applied. I will not go in detail of these two examples because all of you know much about this thing. I will only discuss about the applications where very about which you might not be knowing. So, Alexa is there, Cartona is there, your first Cartona. Um, IBM has its own machine learning platform and they call it as a Watson. So if you go to or if you search for the IBM Watson, you will understand that they have own platform where you can use the computational power, you can use the storage and everything. And there are two applications like IBM Chef and Watson B. They are the where the machine learning is used extensively. Now, chef, people didn't be aware about the dictionary meaning of the chef. So, chef is who? Someone who cook for you, especially in five-star hotels. And whenever you talk about the chef, chef not only cooks the best possible food, but it tries to invent the new recipe. Now, very strange, na? Till now, we always believe that computer cannot do creative job. So, but here to develop new recipe, and in the second example, Watson beat is something called generating a new music. And you people will definitely agree with me. Generating new music is something which is purely creative. So IBM's Watson is making new recipes, which is a domain of the human because it is creative. It is generating the new music so that people like it. So now there is a domain which was completely owned by human being, which is also possible by the machine learning. Now, basically, what does this IBM Chef is doing? IBM Chef basically it tried to go to the molecular level of each and every food. So, for example, there is an um, food called, for example, let us take this lassi, very simple. So it will go to the molecular level of lassi, and then it will identify different molecules which are present in the particular recipe, and then it will try to identify the people who likes those molecules. So if suppose someone is liking someone spicy, then definitely he will like another spicy item as well. So up to that molecular level, this chef Watson is going, and then it is creating new recipes. Netflix, you people definitely know what Netflix is, but you might not be knowing what Netflix is doing with the big data, or what are the data Netflix is capturing from you. So those who have a Netflix subscription available with them, just to convey you, whatever activity you are doing on the Netflix, whether you are watching which channel at which time of the day, in which day of the month, everything Netflix is recording. Few of the time you might would be doing, but you are going back and you are repeating the reviewing the scene. Netflix is recording that as well, and due to that, what it is doing, it is able to recommend you better. For example, if suppose you are looking at particular channel, and there are lot many people who have recommended some other channel which is similar to yours. So what Netflix will do, Netflix will recommend that channel for you, and because both the tests are similar, you will definitely like that particular your that channel, that serial as well. So due to this only, you would be surprised to know Netflix is able to retain 96% of their customer. Now, this is something, when you talk about currently in the world, Netflix has 150 million customers, and from the 150 million, if suppose it is able to retain 90% of the customer, it's a huge number. So the biggest advantage of Netflix is that it is able to retain the customer, and second is that promotion. What a Netflix is doing, Netflix is targeting few people, and then Netflix is giving them free serials, few free channels for some time, and by that it is acquiring new customers as well. Now there is something called Google Translate. I will not go in detail of this because you people know the initial name of Google Translate was a Google Brain Translate. Now, there is a laboratory called Brain in the Google, and the Translate is the product of this brain. So now it is known as the Google Translate, and you people know that it is used to convert statement or words from one language to other language, and it is doing magnificently with the help of the machine learning. Now, where this Google Translate has applied machine learning? See, normally whenever translation is supposed to be done, any particular tool, for example, if suppose we are saying that hello, so this hello, first of all, it will be converted to text and then this text is converted to the text is translated in some other language. For example, if suppose I say hello is equivalent to namaste in Hindi. So if suppose I say hello, so internally this hello will be converted to the textual part, and then this textual part will be converted to the appropriate language, that is a namaste. But with machine learning, it is able to directly convert from the voice. It need not to convert it to textual part. And by this logic, the speed of the translate is much more than any other tool. There is something called magic band. This is available whenever, if suppose someone is going to Disneyland, then he or she is given the magic band, and this magic band, what it is actually, this magic band is an one single point access for everything. If you want to go to hotel, if you want to go to any park, a restaurant, everything, wherever you go, this magic band will always be there with you. And for entry in any of this part, you will need this magic band. Apart from that, your live data, this magic band will send directly to the Disney server for all the further analysis, which ride is something used more, what type of people are using, what type of restaurant, what type of cuisine, how in which part of the day they are more active in the Disneyland. So all these analysis are done with the help of the machine learning, and the data available will be through your magic band. Now, I'm sure all of you must have heard the name Volvo. Volvo is a premium motor manufacturing company of the world. And whenever you hear the term Volvo, it simply means that कि बस है, बहुत ही अच्छी बस है, अच्छी क्वालिटी की बस है. Now, Volvo is something which is using a real-time automobile monitoring. Try to understand what does that mean. Automobile में, whenever you are having some trouble, some problem, when you will realize, आपको कब पता चलेगा कि my automobile, my car, my bike is not working properly. The wear and tear, the problem has started long earlier, long back. But you will realize when the problem reaches to the particular threshold only. But why we should allow the problem to reach to particular threshold? And here is where this real-time monitoring will help. So Volvo has used lot many IoT-based sensors in each of its vehicle, and without your knowledge, the health of the vehicle is directly transferred to the Volvo cloud. And from that Volvo cloud, the data is given to the nearest garage. So that it might be possible, if suppose you are using a Volvo car, you will get a call from the mechanic that, sir, there is this particular problem in the car, and when shall I come to get your car? And even you might not be aware that this problem is still there. So such real-time data, if available with the help of this IoT and sensors, this data is stored on the cloud and analysis is done. You people must be knowing that Google is doing lot many philanthropy activity, and this is one very unique activity which Google is doing about the Google phishing wash. If you want, you can search it on net as well. Now, what this Google phishing net is doing? See, on a daily basis, around more than 2 lakh ships are inside the sea only for the fishing, and there is no communication among them. In fact, at least not centralized communication. Moreover, it may be possible that they may be fishing at the place where they don't have any fish. So we need a global network and a global analyzing system which will help these people, these fishing people, that to identify the right place for the fishing and to stop illegal fishing as well. And here is the this project called the Google's Global Fishing Watch. With the help of the satellite, it is able to track all these vessels. It is able to track all the fishes, the density of the fishes in the particular area, and then it is able to properly guide. Um, G is, I'm sure you must be knowing, it's a general electric. One data according to last year 2020 data, world's 30% electricity power is generated by GE. So it is not something we can ignore. It is one of the largest power generation and power supply company of the world. And with the help of this IoT, now IoT and machine learning, your General Electric is trying to save a lot of the power. Now currently General Electric is in the process of translating from traditional model to the renewable model, and for that reason it is using the IoT and the machine learning. Now American Express is using machine learning for the fraud detection system, and believe me, this is something which is very uh, important thing. See, if suppose on some good day you got the message that there is fraud with your card. Someone has taken out 50,000 rupees from your credit card. Now, what is the purpose of that? See, fraud is done. Ideally, you should stop that fraud. You should detect that fraud before actually fraud happens. Now, is it possible to do? And the answer is yes. American Express is using machine learning algorithms to identify that whether there is a fraud or whether this particular transaction is a legitimate transaction or the particular transaction is a fraudulent transaction. And with 90% of the accuracy, it is able to identify all the frauds. Last example, which is very important in our list, is there is a company called Infervision. It is a Chinese company, and no, see, this is unique example in one way. You will realize that that how your machine learning can be applicable to the domain which is not precisely computer. So the story is like this. If suppose you want to identify that whether there is a tumor, whether there is an cancerous tumor in the lungs or not, you are supposed to do some X-ray. You need to you need to go for X-ray. You need to go for the CT scan, and with that CT scan, you need to go to the radiologist, and then radiologist try to identify whether the cancer is there or not. Now, in China, at that time, there was a severe scarcity of the radiologist. In fact, scarcity of a level where a particular radiologist have to work for 12 to 14 hours per day. Now, this is something which is very dangerous because here radiologist has to be calm, composed, and very precise. And with this, with this such an heavy workload, he will not be able to perform optimally. So what this Infervision have done? Infervision has uh, trained the machine learning algorithm where you will give them the input as the CT scan, and it will give the output as the your whether the particular sample contains the cancer or not. And with 95% accuracy, it is able to detect that whether the particular CT scan has a cancer component or not. In fact, last week I was reading one newspaper article, and very surprising article. The article was that radiologists will be replaced by machine learning. And believe me, it is quite possible to do. In future, we will not need a radiologist. Our machine learning algorithms are equipped enough, they are trained enough to identify whether the cancer is there or not. In fact, last year when I've given a project to my CSE students, one of the students has taken the project of identifying whether there is an COVID situation or whether there is a simple pneumonia from lot many X-ray images available. So with around I think 85% of the accuracy, the algorithm was able to predict that whether this is a pneumonia or whether this is the COVID situation. So these are the domains, medical field. Till now, we were assuming that there is no role of computer there, but now there is a situation where computer can replace your even doctor, your expert as well. So these are some applications of the machine learning. Any query, any question anyone has, then please share with me, and then we'll move ahead.
Sir,
Yeah.
sir, as you told that there are the accuracies of 90%, 92, like that we find the accuracies, then how can we say that the accurate data is going to be true or false? Because that data is on the basis of prediction.
Good question, Darpan. See, no one can say with 100% surety that the output is this only. For example, if I talk about this card fraud detection, with 100% accuracy, no one can say that the particular transaction is a authenticated transaction or a particular transaction is a fraudulent transaction. We will always get this percentage only whenever you talk about this machine learning algorithm. Now, actually, how this machine learning algorithm works, we will see it in detail later on, but just let me give you one very brief thing. In machine learning algorithm, there is something called training and there is something called testing. For any machine learning algorithm, you have to run on these two stages. One is for training, another is the testing. Now, during the training, you will give lot many training data to the machine learning algorithm. And with that, your machine learning algorithm is trained. Now, machine learning algorithm is trained for that. Trained for what? It is trained for the particular type of the problem. For example, if suppose I want to develop one attendance system, and what I will do, I will put one camera on the door, and whoever is coming inside, I will capture the picture, and I will try to predict. I will try to identify who that particular person is. So, for example, there are 100 employees in the organization and they move for around 1000 times in a day. So you have 1000 samples for the particular this input to the machine learning algorithm. Now out of this 1000, you will not use all this 1000 to train. What you will do, ideally we train it with 80% of the data. So randomly out of this 1000, you will pick the 800 records, you will train your machine learning model, and then with the remaining 200 records randomly taken, what you will do, you will now check that whether the particular algorithm is trained properly or not. Now, whatever 80%, 90%, or 95%, the number you are saying, that number is out of this 20% only. In our case, out of this 200 observations only. So, for example, out of these 200 observations, it is able to identify, for example, 180 observations correctly, and it is not able to identify 20 observations correctly. In that case, the accuracy will be 90% of the particular algorithm. So it also means that 20% observations are still there which the algorithm is not able to identify properly. Darpan, got it?
Yes, sir.
Yeah. Anyone else? Okay, so we are moving forward. Let us understand the relationship between your this terminology and in fact, most of the people, they assume that artificial intelligence is machine learning, but no, it is not like that. This is my set theory diagram, and all of you can easily um, understand that artificial intelligence is the superset of all. So in artificial intelligence, there is something called machine learning. So if I ask you that what is the relationship between machine learning and artificial intelligence, you can always say that machine learning is the subset of the artificial intelligence. So if it is a subset of the artificial intelligence, what else will be there? There are a lot many other algorithms. There is something called form intelligence. There is something called genetic algorithm. There is something called fuzzy logic. They all are the part of the artificial intelligence. But apart from all this, there is something called machine learning as well. Take my words. In today's time, nothing is more important than machine learning. all the algorithms which I have said you, whether it is your farm optimization or I say genetic algorithm, they are not working fine. I mean, of course they are working fine, but they are not used a lot. Only machine learning is used a lot. Now, machine learning algorithms, to implement machine learning, there are lot many different algorithms. There is something called, for example, I've used the terminology called SVM just now. Support vector machine is there. There is something called naive Bayes. There is something called linear regression. And there is something called artificial neural network. So in machine learning, there are lot many different algorithms. And among these, there is one algorithm called the artificial neural network. And deep learning is the application of this artificial neural network. So in this, whenever you use this ANN extensively with lot many different layers, with lot many dropouts, in that case, you will call it as a deep learning. So your deep learning is a subset of the neural network, which is a subset of the machine learning, and which is the subset of the artificial intelligence. So am I clear, everyone? Yeah, any question in this?
So can we keep artificial intelligence, machine learning, neural network, deep learning as a subset of IoT or not?
Hmm. Good question. Let me to explain this. Let me go to the basics of this thing. Um, if I ask you, any of you, what is the computer program? So, can anyone give me any lucid definition of computer program?
It's what we
Any
know
Kavya or
in computer languages that expresses in the computer languages.
okay, something, but Darpan, we cannot write any XYZ thing, na? We have to do with some purpose.
Set of instructions
Right, Mandar, set of the instructions, but for what?
for informing computer about a task to perform.
Right.
That's
So to achieve a particular goal, right? Na? So in fact, in general, if I say computer program is a set of the instructions which will transform a particular input to the particular output. So for example, if suppose I have written a program to add two numbers, what will be the input? Your input will be two numbers, for example, A and B, and output will be the summation of both the numbers, A plus B. So any computing system, it consists of three parts. Number one, input. Number two, processing, which is where your computer program is there. And number three, output. Now, machine learning is all about that processing. Machine learning has nothing to do with your input or the output. In fact, whenever you will train this machine learning, you have to explicitly pass on the data in the form of the Excel file. So machine learning is all about this processing. Then in the entire chain, entire cycle, where does your IoT will stand? Now, whenever you talk about the IoT, can anyone give me any example of the IoT so that I can explain it in this context? Any example?
Smart home,
Smart?
so smart home like smart electricity devices are there.
Ah, right. Smart home, which is example of the IoT. Now, smart home, let us take one very basic couple of examples of the smart home. So you have your smart home where you need not to carry the key, as in when you go to the door will automatically open, as in when you get inside, the door will automatically close. That is one thing. You have had an ambience assisted lighting system with the help of the IoT. So what it will do, it will check that what is the current luminance outside, and accordingly it will turn on the light with the particular intensity. So in the evening, in the morning, the intensity will be low. In the night, the intensity will be high of the light. So for both these applications, what is the input, what is the output, and what is the processing? So, for example, if I talk about your first example, your authentication example, what is the input?
That the user coming should be verified.
No, no, it is the output. It is not the input. What is the input in this case?
So user itself is a input.
हाँ नहीं, user is the input, right? But user is the input for you. User is not the input for the IoT system or for the smart home. स्मार्ट होम के लिए यू व्हाट इज द इनपुट? इनपुट इज द इमेज ऑफ यूजर। नो, वहां पे यूजर भी हो सकता है, वहां पे कोई कुरियर बॉय भी हो सकता है, कोई भी हो सकता है। सो इनपुट टू दिस पर्टिकुलर सिस्टम विल बी द इमेज। ऑल ऑफ यू एग्री?
Yes, sir.
Yeah, and then the processing will happen, some processing will happen, and what will be the result? The door will be open. So automatically the door will be open, and even when the person get inside, automatically the door will be closed. Now here there are different things involved. Number one, for the input, you need to capture the image. You are using the camera. Now what is the camera? Camera is the sensor. So in the IoT, whenever you talk about the IoT is all about your input with the help of the sensors, your actions in the form of some algorithm that may be machine learning algorithm, that may not be machine learning algorithm, and output in the form of the actuator. Now what is this actuator? Whenever the door is open or door is closed, so who is doing this? There is a mechanical motor which is doing this, and it is known as the actuator. In our lighting wala example, what will be the input? You have a sensor called a DHT sensor, which will measure the current lighting situation. If the lighting is appropriate, then it will process, and then it will tell the actuator that there is no need to start the street light. If the lighting is not proper, who will analyze? Of course, your processing unit will analyze, and then it will tell the output that now you are supposed to turn on the lighting. So in the IoT itself is a system where there is an input, there is a processing, and there is an output in the form of the actuation. Now, this processing for the normal IoT application can be easily done without machine learning, but for the complex problem, you need to have the machine learning. आपको machine learning इस्तेमाल इसमें करना पड़ेगा. Now, clear the relationship between these two things?
Yes, sir.
Any other question regarding this? Okay, so let us go to some history about the machine learning. Now, this is going to be a little bit theoretical, just bear with me. Okay, machine learning is not something which has come up just recently. Machine learning की जो definition आई थी, it came in 1959 by Arthur Samuel, and the definition was very generic, very lucid definition. Field of the study that gives a computer the ability to learn without being explicitly programmed. Now very interesting है ये word जो है ना, without being explicitly programmed, इसको अपने mind में fit कर लेना, क्योंकि machine learning is all about this. In the machine learning, you need not to program your application for the particular type of the problem. So ये आया था 1959 में. But in 2000, machine learning get more recognition, and the reason was very simple. That before 2000 or before 2010, our computational power was not big enough, because to try to understand, and tomorrow we will see as well, that whenever you are running any machine learning algorithm, even if you have a supercomputer, it will take a lot of time, because to run a machine learning algorithm, the computer is doing lot many permutation combinations before giving you the result. So it is taking a lot of time, lot of effort, and such computation power, such storage was not available at that time, and that was the reason machine learning was not that much popular. But now, because we have a computational power, we have a huge storage on the cloud, Now ML is considered as a much better option. So in 1997, a much proper definition was given by Tom Michel. The definition is very simple. A computer program is said to learn from the experience E with respect to some task T and some performance measure P. If its perform on T as measured by P, improve the experience E. So you have lot many experiences. Now these experiences are in the form of observations. So after every observation you apply on the machine learning algorithm, the performance of the algorithm should be improved. It should be better. So finally, when you will apply the last training set, last training experience, you will get a more or less perfect machine learning algorithm. So if I want to compare a traditional programming with machine learning, and this is something which is very relevant. So whenever you talk about any traditional programming, what you will give to the computer, you will give a program जो आप लोग वहां पे जाके रन करोगे. You will give a data, and based on that data you will get some output. But machine learning is little bit different than this. In the machine learning, you will get the data, you will get the output as well, and you will get the program. So you will give data, you will give output, and you will get the program. Now this program you can give with other data to get the appropriate output. So here you are not going to write the program, you are going to get the program from the computer whenever you will apply the machine learning. इसको इस डायग्राम को ध्यान में रख लेना अपने दिमाग में, ये बहुत काम का है, क्योंकि it is a difference between your traditional programming language and machine learning. Any question about this? Okay, so now let us go in little bit more detail about the machine learning. So as you know now that it is the application of AI that provides system the ability to automatically learn and improve from the experience. The process of learning begins with observations or data. So you will be having observations, lot many observations. Now, what is this observations? If suppose, as I've said you, that in our automatic attendance system, for example, if suppose I don't want to go for the manual attendance system in the university, I have to design a system which will take automatic attendance of the students. So I will put one camera just above my blackboard, and what does this camera will do? This camera will periodically capture the images. So entire class is sitting in front of the camera. It is periodically capturing the images, and then it is trying to identify that who that particular person is, whether that person is Shell, whether that person is Priyanka or Kavya. It is trying to identify who that particular person is. Now, before that, so this is the actually operation. Now, before this operation, you are supposed to give lot many observations of each and every individual. So, for example, it might would be possible that I may have to give 100 images of shell to the computer system so that it can learn that particular object is a shell only. I may have to give, for example, 100 images of the mandar to identify that the particular person is a mandar only. So this 100 images of shell, 100 images of mandar, and by that way, all the 100, at least 100 photograph of each and every individual from the class, then it will become the observation, it will become the data. Now this entire data, this entire observation will be given to the machine learning to learn, and even when the machine learning learn, it will try to predict the person whenever there is a live situation going on. So there are different type of machine learning algorithms. One is a supervised machine learning, and there is a unsupervised machine learning. Third one is a reinforced learning. Anyone having any idea about this different type of algorithms? अगर नहीं भी है तो चिंता की बात नहीं है, वी आर गोइंग टू अंडरस्टैंड ऑल दिस। नाउ एक बात ध्यान रखना, यू कैन नॉट say that X algorithm, X approach is better than another approach. मतलब आप में से कोई बोल सकता है कि सर I will use reinforced learning because it is better than supervised learning, or I will use unsupervised learning because it is better than the reinforcement learning. No one can say that. Let me tell you why. These are the approaches which are applicable to different type of problems. So if suppose there is a problem which has to be solved by supervised learning, you cannot solve that problem by unsupervised. You cannot solve that problem by reinforcement. If there is a problem which has to solve by reinforcement learning, you cannot solve it by supervised. There is no, you cannot even think about that. So by that logic, there is no algorithm which is better than the other algorithm. But yes, situation wise, you can say that in the particular situation, you can apply the particular algorithm only. You cannot apply particular algorithm. So we have a three categories of this approaches. One is a supervised, another is a unsupervised, and reinforcement learning. Whatever algorithm you are going to study, or whatever algorithm you know, for example, support vector machine, artificial neural network, CNN, whatever you know, CNN cannot be considered here because CNN is not the part of the ML, it is part of the your deep learning. So whatever algorithm you know, KNN, they all will be falling in either one or the other of this approach. So first of all, let us discuss about the your supervised machine learning algorithm. Now, whenever you talk about the supervised, um, you will be having and labeled data. Now, what do you mean by labeled data? Let us consider one example. So, आपके पास एक फॉर एग्जाम्पल एक फ्रूट बास्केट है जिसके अंदर यू हैव लॉट मेनी फ्रूट्स. You have an apple, you have a mango, you have one dozen banana, you have a couple of pineapples, you have three or four guava. So you have a fruit basket. So whether you know which fruit is which, आपको पता है कौन सा फ्रूट कौन सा है? And the answer is yes. If suppose I pick something and if I ask that which fruit is this, and immediately you will say that this fruit is this. That is known as the labeling. So if suppose you have a data, आपके पास अगर डेटा है और वो डेटा के अंदर आपको पता है कि इसका आउटपुट क्या है, what is the result, what is the output of this particular observation, then it is known as the label. In the supervised machine learning algorithm, we will always be using the labeled data. हम लोग कभी भी unlabeled data को use नहीं कर सकते. हम इसको हमेशा labeled data को ही हमें इसको use करना पड़ेगा. So, and believe me, majority of the machine learning falls under this criteria only. हम ज्यादा से जितने maximum cases होंगे वो आपके इसी category में fall हो रहे होंगे. So what you will do, you will give a data observation with the label. So for example, if suppose मुझे ये जो फ्रूट बास्केट में से कौन सा फ्रूट है वो प्रेडिक्ट करने के लिए आई नीड टू हैव एल्गोरिथम. सो इन दैट केस व्हाट आई विल डू, I will find 100 images of banana, 100 images of your apple, 100 images of guava, 100 images of pineapple, and I know that this 100 are of banana, this 100 are of the guava. Now when you talk about the banana, it may be possible that you have an image with single banana, you have a one image with a bunch of bananas, you have an image with yellow banana, you have an image with what you can say greenish banana. So different type of diversified data you have for each and every this label, and then you will put the entire this data set in the machine learning algorithm to train this machine learning algorithm, so that next time whenever you show any fruit, now if that fruit is found from the this trained data, then it will definitely tell you that this fruit is banana or the apple or the pineapple. So for the input data, if suppose you have input as well as the output label, this category is known as the supervised machine learning. Now, so starting from the analysis of the known training data, the learning algorithm produces an inferred function to make a prediction about the output value. The learning algorithm can also compare its output with the correct. So basically, what it is doing, what the algorithm is doing, जैसे आपने एक fruit बताया, for example, if suppose that fruit is mango, and system identified that it is as banana. So actual fruit is mango, but system identified it as a banana. So what the program will do, this machine learning algorithm will try to improve itself. It will try to make sure that next time whenever this is shown, it shows that it is the mango, not the banana. So the the basic idea behind machine learning, supervised machine learning algorithm is to minimize this error. जो भी errors होंगी उसको हमें minimize करने हैं. Now, supervised के अंदर भी you have a couple of category. One is a regression, another is the classification, and did anyone having any idea about regression or the classification approach? एक काम करते हैं, चलो नहीं आपसे नहीं पूछता हूँ. Let me give you example. See, for example, मैं आप लोगों का रिजल्ट देख रहा हूँ. For example, मैंने दर्पण का रिजल्ट देखा. सो सेमेस्टर 1 में फॉर एग्जांपल 7.5 एसजीपीए थे. सेमेस्टर 2 के अंदर 8 हुए, सेमेस्टर 3 के अंदर 8.5 हुए, सेमेस्टर 4 के अंदर फॉर एग्जांपल कम हो गए, 7.2 हो गए, सेमेस्टर 5 के अंदर कुछ आए. नाउ बेस्ड ऑन दिस पास डेटा, कैन आई प्रेडिक्ट द रिजल्ट of the semester 6? क्या मैं प्रेडिक्ट कर सकता हूं? And the answer is yes, up to certain extent I can do that. So based on this approach, मैंने एक वैल्यू प्रेडिक्ट किया कि सेमेस्टर 6 में दर्पण के 8.0 आएंगे. See, I may be right, I may not be right. ये भी हो सकता है कि 8.0 आए, ये भी हो सकता है कि 7.9 आए, 8.5 आए, कुछ भी आ सकता है. But what I am getting is the value. मुझे क्या मिल रहा है यहाँ पे? वैल्यू मिल रहा है. So in the regression analysis, in the regression supervised approach, you will always get the value. For example, मैं I'm trying to identify कि कल की डेट में इंडिया में कोविड के पेशेंट कितने नए आएंगे. So I have a data of past 6 months. I will put this data in my machine learning algorithm, and with that machine learning algorithm will give me some value. Machine learning algorithm ने बोला कि कल के आपके जो डेटा आएंगे वो 15,420 आएंगे. So I got some value. Now actual observation, actual result would be this value or would be somewhat closer to that. But actually whatever be the case, you will get always the some value. आपको हमेशा कोई ना कोई वैल्यू मिलेगी. Now this is known as the regression. So the approach in which if suppose you are going to get the value, this is known as the regression. That is one category. Second type of the supervised machine learning is a classification. So अगर मैं उसी दर्पण का जो एग्जांपल हमने लिया था, if I continue with the same example, so if I ask दर्पण, मेरे पास दर्पण का पिछले 5 सेमेस्टर का रिजल्ट है. अब I want to identify, I want to find out whether Darpan will pass in the semester 6 or not. So I have that data available with me. I have a data semester 1 pass, semester 2 pass, semester 3 pass, semester 4 pass, semester 5 pass. Semester 6, based on the past observation, can I able to predict that a particular student will pass or fail? And the answer is yes, up to certain extent I can definitely predict. So here the prediction will be whether pass or fail. In certain cases, it would be possible that you would like to predict from more than 2 classes. जैसे हमारा आगे वाला एग्जांपल था कि मेरे जो फ्रूट्स थे वो कौन कौन से थे. एप्पल थे, बनाना था, पाइनएप्पल था, गुआवा था. तो मेरे 4 अलग अलग फ्रूट थे. Now whatever fruit you are trying to predict, it will be from these four different fruits only. So what I am doing, I am classifying this observation into different categories. पहले केस में हमने क्या किया, हमने पास फेल किया. दूसरे केस में हमने क्या किया, हमने उसको चार फ्रूट में से कोई भी एक फ्रूटों का वैसा डिवाइड किया. So here you will not get the absolute number. रिग्रेशन में कभी भी आपको एब्सोल्यूट नंबर नहीं मिलेगा. रिग्रेशन के अंदर आपको हमेशा क्लास मिलेगा कि पर्टिकुलर ऑब्जर्वेशन कौन से क्लास का है कि नहीं है ना. मैं आपको फॉर एग्जांपल इफ आई टॉक अबाउट माय रिसर्च, जो मेरा रिसर्च है वो क्लासिफिकेशन टाइप के अंडर है, बट आई हैव मॉडिफाइड इट. मैंने कैसे मॉडिफाई किया, जैसा लेट मी शेयर विथ यू. So mine is a stock prediction, but with little bit variation. So normally people try to predict the price of the stock. मतलब आज for example 100 rupees है, एक साल के बाद कितनी होगी, 2 साल के बाद कितनी होगी, 3 साल के बाद कितनी होगी. तो वो कौन सी कैटेगरी में आएगा, रिग्रेशन वाली कैटेगरी में आएगा. बट व्हाट आई एम डूइंग, आई एम एज्यूमिंग दैट मेरे लिए अच्छा स्टॉक कौन सा है जो मुझे कंसिस्टेंटली 15% या 20% रिटर्न दे. मतलब आज अगर उसका 100 है, एक साल के बाद 1150 होना चाहिए, नेक्स्ट ईयर 132 होना चाहिए, उसके बाद 156 होना चाहिए. ये होना चाहिए. अगर ये नहीं होता है देन इट इज नॉट अ गुड स्टॉक. तो जो रिग्रेशन वाला प्रॉब्लम था, मैंने उसी को कन्वर्ट कर दिया क्लासिफिकेशन के अंदर, वेदर दिस इज अ गुड स्टॉक और इट इज नॉट द गुड स्टॉक. सो by this way you can have this switch as well, regression to classification, classification to regression as well. But classification is something you are classifying your observation into different classes, and regression is that you are trying to predict the particular value. Now this two, regression approach and classification approach, हम लोग अभी थोड़ा सा डिटेल में भी देखने वाले हैं, तब आपको ज्यादा इसमें आइडिया आएगा. बट एनी क्वेश्चन टिल नाउ अबाउट दिस सुपरवाइज्ड मशीन लर्निंग अप्रोच? Okay. Next is unsupervised, and most importantly, in the unsupervised learning, we don't have a label. तो आपको डेटा दे दिया जाएगा, but then you don't have any label. So very interesting, ना? You don't have a label. How to predict? So, for example, if suppose जैसे for example, take any superstore, and superstore आपका बिल बनाता है. Now, whether that data can be used somehow, क्या वो डेटा किसी वे में यूज हो सकता है? Yes, हो सकता है. फॉर एग्जाम्पल, आपने एक बिल बनाया, आपके बिल में जितने भी आपने आइटम्स खरीदे थे सुपर स्टोर से, या फॉर एग्जाम्पल आप कोई ब्रांड फैक्ट्री जैसा शोरूम ले लो, आपने बिल बनाया, वो बिल में आपने कौन कौन सी चीजें साथ में खरीदी हैं, वेदर दैट कंपेरिजन कैन बी डन, एंड द आंसर इज यस. Here there is no label, there is nothing like right and wrong, there is nothing like apple banana, there is nothing like today is 100 that means tomorrow it will be 125. No, you are trying to cluster the similar observations. You are trying to associate one observation with the another observation. So I mean आप लोगों ने जो ये प्रेडिक्शन सिस्टम देखी होगी फ्लिपकार्ट या अमेजोन के ऊपर, नीचे वो हमेशा आपको प्रेडिक्ट करके बताता है कि this may be of your interest. Now, how it is doing that? So what it is doing, it is trying to find out the association of something what you have purchased with someone else who has purchased in the past. अगर किसी ने पास में कुछ परचेज किया है, उसके साथ एसोसिएशन करके वो नीचे रिकमेंडेशन आपको वो देता है. सिमिलर रिकमेंडेशन विल बी इन योर YouTube, in your Netflix, everywhere. So they all will come under your unsupervised machine learning. They are not the part of the supervised machine learning where we are trying to predict the exact value. Here what we will do, we will try to cluster, we will try to group these observations, and next time whenever any new observation comes, we will check the parameter and we will see that this parameter is closest to which group, which cluster, and then we will say now this can be applicable. So here you will not be having any label, आप डेटा को क्लस्टर के फॉर्म में ऑर्गेनाइज करोगे या तो एसोसिएशन एस्टैब्लिश करोगे. सो इन अनसुपरवाइज्ड लर्निंग, what does this machine learning algorithm is doing? It is trying to find out the hidden pattern, hidden structure among the data, which is very difficult for us to do that. So this is about the unsupervised machine learning algorithm. Any question about this? See, right now I'm giving all of you an introduction about few things. By the end of this session, I will share this updated PPT with Darpan, and I'm sure you people will get it maybe within an hour or so. So these topics you go through in, and if in any of the topic, if you are not able to understand or if you are not able to correlate it properly, tomorrow we have one more session for 15-20 minutes. We will dedicate for the discussion only, and then we will move forward. So till now, any question in supervised machine learning? Okay. Now in both these approaches, either you talk about the supervised or the unsupervised, the basic idea is that you will give all the data simultaneously to the machine learning algorithm. You will give all data at one time, and the machine learning algorithm will improve based on that data. Now here there is a third approach, which is a reinforcement machine learning. And in the reinforcement machine learning, it is a punishment reward policy, you will say. For example, if suppose you have an algorithm, and you have given the algorithm some input, and so the appropriate output is given, appropriate action is given. Now if suppose that particular action is appropriate, it is right, then the reward will be given to the algorithm. If suppose it is not right, it is not appropriate, some punishment will be given to the algorithm. So in the reinforcement learning, you are not going to get all the data, you are not going to give all the data to the algorithm simultaneously. You will give data one by one to your algorithm. Now, reinforcement learning is mostly used in the applications like robotics. In this robotics, you will give one observation, one data at one time. It will try to predict some output. If it is appropriate, if it is right, in that case, the positive reward is given. And if it is not able to do, then some punishment will be given. So this reward punishment, reward feedback mechanism will work with your reinforcement learning. So wherever there is an what you can say, a robotic type of example, you can always use the reinforcement learning. There are two approaches like MDP, Markov decision process, and Q learning are mostly used in the reinforcement learning. Reinforcement learning is all about the probability. Here largely we will be dealing with the probability. So with what probability we say that the particular output is true or not. So this is about the reinforcement learning. Now when to use what, कब क्या use करना, उसके लिए वो भी बहुत interesting है. So whenever you have a labeled data, there is no question, you go for the supervised approach. Whenever you have unlabeled data and the interaction is real-time interaction, go for the reinforcement learning. And whenever there is no real-time interaction, go for the unsupervised learning. Whenever you have a huge unlabeled data and no real-time interaction is needed, go for the unsupervised learning. Try to understand the data requirement in the unsupervised learning lot more than both of these approaches. So the highest requirement will be in this unsupervised learning. The lowest requirement will be reinforcement. If you multiply the requirement, if that number by, for example, 10 times, for example, for the particular training, you need 10 observations in the reinforcement. You will need 100 observations in the supervised, and you will need 1000 observations in unsupervised. So if suppose depending on the data as well, you can decide that what type of approach you are supposed to implement. So with this, we have completed different types or different approaches for the machine learning. Any question about any of this approach? Okay, I'm moving forward. Now, there are certain situations where you have to use your reinforcement learning. You don't have flexibility of using your supervised learning. So let us see how they are different, your supervised learning and reinforcement learning. Um, Decision style is different. Now, how decision style is different? In the reinforcement learning, you take the decision sequentially. मतलब आप क्या कर रहे हो, आप डिसीजन को वन बाय वन ले रहे हो. पहले आपने डिसीजन लिया, यू टेकन द एक्शन, देन डिसीजन लिया, देन टेकन द एक्शन, देन डिसीजन लिया एंड सो ऑन. सो फॉर एग्जाम्पल आपने एक रोबोट बनाया एंड दैट रोबोट का जो टास्क है इट इज टू roam inside the room. So input will be whatever the robot is looking at. Robot क्या देख रहा है वो उसका input हुआ image. What will be the output? The direction help. For example सामने wall आ गई है, so you are supposed to move it in either left hand direction or the right hand direction. In that case, so if suppose the decision is sequential, which is the case here, we have to use reinforcement. अगर आपका डिसीजन सीक्वेंशियल नहीं है, then you have to use the supervised learning. Now where it will be helpful, reinforcement learning works on the where there is a interaction with the environment. आपकी environment के साथ continuous interaction हो रहा हो. अगर एक continuous interaction नहीं हो रहा है, if you have a sample data available with you, go for the supervised learning. And believe me, in majority of the cases you will be given lot of the data. डिपेंडेंसी ऑन द डिसीजन. ना फॉर एग्जांपल एक रोबोट मूव कर रहा है, तो आपने पहले उसको स्ट्रेट ले गए, फिर आपने देखा वॉल आ गई, फिर आपने उसको लेफ्ट में मूव किया, फिर आपने देखा आगे फिर से वॉल आ गई, फिर आप उसको कहाँ पे राइट में मूव करोगे या लेफ्ट में मूव करोगे. सो योर पास्ट डिसीजंस आर आल्सो इंपॉर्टेंट. व्हेनेवर यू टॉक अबाउट द रीइंफोर्समेंट लर्निंग, आपके पास्ट डिसीजन के ऊपर डिपेंडेंसी ज्यादा होगी इन कंपेरिजन टू द सुपरवाइज. सुपरवाइज में कोई डिपेंडेंसी नहीं होती है. Every observation is a new observation. Every decision is a unique decision. Best suited किसके लिए काम करेगा? फॉर द जहाँ पे ह्यूमन इंटरेक्शन है उसके लिए रीइंफोर्समेंट काम करेगा, और जहाँ पे सॉफ्टवेयर में आपको एप्लीकेशन में यूज करना है वहां पे आप लोग सुपरवाइज यूज करेंगे. चेस का गेम इज अ बेस्ट एग्जांपल ऑफ द रीइंफोर्समेंट लर्निंग. एंड योर ऑब्जेक्ट रिकग्नाइजेशन, हमने अभी जो बोला जैसे मैंगो है, बनाना है, इट विल कम अंडर द सुपरवाइज लर्निंग. So different, that is what I said, you don't have single algorithm which is best suitable for all type of problems. Depending on the situation, depending on type of data, you have to identify the right algorithm. So ये difference था. For any machine learning, किसी भी machine learning के लिए कौन कौन सी चीजें सबसे ज्यादा important है? Number one, data set. Now what type of data is available to you, and based on that data you have to extract the features, and these features will be applied to the model in the form of the inputs, and then this model will be evaluated. इस model को हम लोग क्या करेंगे? Evaluate करेंगे. So data set is very important. Now normally आपको जो भी data set मिलेगा, वो डेटा सेट आपको अप्रोप्रिएट फॉर्मेट में नहीं मिलेगा. मैं आपको सिंपल, लेट मी गिव यू वन एग्जांपल. यू आर डूइंग सम एक्सरे एनालिसिस. नाउ इन द एक्सरे एनालिसिस आपको डेटा सेट में क्या मिला? यू विल गेट नंबर ऑफ एक्सरे. फॉर एग्जांपल आपको 1000 एक्सरे मिले, 1000 एक्सरेज की इमेजेस मिली. नाउ वो आपका डेटा सेट हुआ. बट फॉर एग्जांपल इफ सपोज यू वांट टू आइडेंटिफाई वेदर ट्यूमर इज देयर और नॉट, तो आपको क्या करना पड़ेगा? यू नीड टू आइडेंटिफाई द लोकेशंस, द पोजीशंस जहां पे आपके व्हाइट कलर के सेल्स ज्यादा हैं, तो और कितनी इंटेंसिटी के सेल्स हैं. सो दिस जो प्रोसेस हमने किया व्हाइट कलर के सेल्स को आइडेंटिफाई करने का, जो हमने प्रोसेस किया, दैट प्रोसेस इज नोन एज द फीचर एक्सट्रैक्शन. यू कैन नॉट गिव एंटायर डेटा सेट टू द योर मॉडल, टू द algorithm. You need to extract the feature from the data set, and then these features will be given to the algorithm. Now once the algorithm is trained, you need to evaluate the algorithm. Now जैसे अभी हमने बोला कि ये algorithm 95% accurate है. So accuracy is one of the evaluation parameter, but there are lot many others. Accuracy के अलावा there is something called precision, F1 score, ऐसे बहुत सारे parameters हैं. अकेला accuracy नहीं है. So these are the four components of any machine learning approach. One is a data set, another is a feature extraction, then model representation, and then the evaluation. Let us see. Now, before we go to that, एक हम लोग just थोड़ा सा एक रियल टाइम कंपैरिजन कर लेते हैं. So if we talk about the data features and algorithm, this is how they are there in the real world. So अगर मैं if I have a data and I have algorithm, so I'm applying some approaches on my what you can say data with the help of the algorithm. This is known as the data mining. Now अगर आपके पास फीचर्स हैं और आपके पास algorithm हैं, फीचर्स का मतलब है फॉर एग्जांपल आई वांट टू फाइंड द एडिशन ऑफ टू नंबर्स, तो जो दो नंबर ए और बी आई एम पासिंग, दे आर द फीचर्स. So if I have the features and I have an algorithm, I will call it as a classical programming. Then what is the data science? आपके पास बहुत बड़ा डेटा, ह्यूज डेटा यू आर गेटिंग. ये डेटा में से रिलेवेंट फीचर को आइडेंटिफाई करने की जो टेक्निक है, इसको हम लोग क्या बोलते हैं? वी आर कॉलिंग इट एज अ डेटा साइंस. सो दिस इज अ वेरी वेरी lucid comparison between this relationship between data, feature and algorithm. लेकिन अगर आप तीनों को कंबाइन करते हो तो इन दैट केस ये अप्रोच को हम लोग बोलते हैं मशीन लर्निंग अप्रोच. Any question about these two things, components and this small little diagram? So जो लोग जो मेरे स्टूडेंट्स अभी डेटा साइंस हैं कर रहे हैं, see machine learning consists of few other things as well apart from simply the data science. From the diagram you can simply make it. So if suppose you want to enhance your skills, then you need to acquire some of the machine learning skills as well. In the data science you might not get all the machine learning skills. Okay. Okay, so we are moving now. Let us first of all take the first component, which is a data set. And see, I've given you few example of the data set. हमारा जो हमने example दिया, images, X-ray images is one example. In my case, अगर मैं मेरी बात करूँ stock prediction के लिए अंदर, so what I am getting the price data of the particular stock of last 10 years. तो ये मेरा क्या हो गया? ये मेरा डेटा सेट हो गया. पिछले 10 साल का हर एक मतलब पर्टिकुलर स्टॉक, फॉर एग्जांपल मैंने एक स्टॉक लिया रिलायंस, तो रिलायंस स्टॉक के पिछले 10 साल का जो भी डेली क्लोजिंग प्राइस होगी वो मेरा क्या हो गया? इट इज माय डेटा सेट. सो डेटा सेट इज वेरी इंपॉर्टेंट. अपार्ट फ्रॉम दैट एक और चीज ध्यान रखना, फॉर ट्रेनिंग एनी मशीन लर्निंग एल्गोरिथम, your diversified data set is always better. So मैं आपको सिंपल एग्जांपल बताता हूँ. फॉर एग्जांपल मुझे एक फ्रूट क्लासिफिकेशन के लिए ट्रेन करना है. तो 100 ऑब्जर्वेशंस मैंने लिए, 100 इमेजेस लिए, जिसमें से 99 मैंगो से और 1 बनाना है. तो आई विल ट्रेन माय एल्गोरिथम विद 99 मैंगो एंड 1 बनाना. तो दिस इज नॉट अ डाइवर्सिफाइड. यहाँ पे मैंगो ज्यादा है और आपका बनाना सिर्फ जो मिनिमम ऑब्जर्वेशन. नाउ विथ ओनली 1 ऑब्जर्वेशन योर एल्गोरिथम विल नॉट बी ट्रेन्ड प्रॉपर्ली. आपका एल्गोरिथम प्रॉपर्ली ट्रेन नहीं होगा. मैंगो को प्रॉपर्ली रिकग्नाइज कर लेगा वो, लेकिन बनाना को प्रॉपर्ली रिकग्नाइज नहीं करेगा क्योंकि आपका डेटा डाइवर्सिफाइड नहीं है. सो ऑलवेज व्हेनेवर यू ट्रेन एनी मशीन लर्निंग एल्गोरिथम, ऑलवेज मेक श्योर कि आपका डेटा प्रॉपर्ली डाइवर्सिफाइड हो. अब हम लोग क्या करेंगे? हम लोग हमारे ये जो फ्रूट क्लासिफिकेशन है, इसी एग्जांपल को हम आगे लेके जाएंगे टू अंडरस्टैंड ऑल दिस डिफरेंट कंपोनेंट्स. फॉर एग्जांपल मुझे फ्रूट क्लासिफिकेशन के लिए एक डेटा सेट बनाना है. इन दैट केस मेरे पास एक डाइवर्सिफाइड, आई नीड टू हैव अ डेटा सेट. आई नीड टू हैव फॉर एग्जांपल आई नीड टू आइडेंटिफाई 3 fruits, mango, banana and apple. I need to identify these 3 fruits. So what I will need, I will need diversified data of all these 3 fruits. So what I will need, मुझे सबके 100 images देने पड़ेंगे. 100 mango images, 100 apple images, 100 banana images. Now when I will give this 100 images for of this, I mean अगर मुझे फॉर एग्जांपल मैंगो की इमेजेस नहीं मिल रही हैं तो कोई इंटेलिजेंट कोई स्मार्ट स्टूडेंट क्या करेगा, एक ही मैंगो की 100 कॉपीज बनाएगा, मतलब मैंगो 1, मैंगो 2, मैंगो 3, मैंगो 4, सिमिलरली टिल मैंगो 100, और एल्गोरिदम के अंदर सेम मैंगो की इमेज को 100 बार डालेगा। दैट कैन नॉट बी डन। आपने नंबर ऑफ डेटा बढ़ा दिए बट आपने डाइवर्सिफिकेशन नहीं बढ़ाया। सो आपको मैंगो देना पड़ेगा, एंड मैंगो दैट टू फ्रॉम डिफरेंट एंगल, फ्रॉम डिफरेंट डिस्टेंसेस ऑफ डिफरेंट कलर्स to properly train your algorithm. So, any question about the data set, especially this example or any other example?
Sir, yeah, question is like you said that we collect the data. So if we collect data, we are going to collect data from a source. If the source provides just some of the data that are false, then how this algorithm going to predict? Because the prediction will always go towards the false data.
Good, very, very good, Darpan. In fact, when you talk about the different steps of machine learning, डेटा एक्विजिशन के बाद एक दूसरा स्टेज आता है डेटा क्लींजिंग का, डेटा क्लींजिंग एंड डेटा फिल्टरिंग का। Now, what is this data cleansing and data filtering? You will try to identify, you will try to predict this type of false data. ये उसके लिए आपको अलग से एल्गोरिथम लिखना पड़ेगा जो आपके जो डेटा सेट में से गलत ऑब्जर्वेशंस को निकाले। तो या वो करना जरूरी है, वो आपको करना पड़ेगा। वो मैंने स्टेप्स यहाँ पे स्टेप कवर नहीं किया, बट या दैट प्रोसेस इज रिक्वायर्ड। यू नीड टू क्लीन योर डेटा so that only right data will be entered. Now try to understand one thing, Darpan, in this case two different type of things we are talking about. Number one, जैसे मैंने मैंगो का एग्जांपल लिया, अब मैंगो के बदले में पाइनएप्पल डाल देता हूं, दैट इज रॉन्ग डेटा, दैट डेटा हैज टू बी रिमूव। बट फॉर एग्जांपल अगर मैंगो के बदले एक एक भले छोटी सी, एक बिल्कुल बैर मिनिमम छोटी सी मैंगो है, that is not the wrong data. या तो फॉर एग्जांपल एक rotten mango है, that is also not the bad data. So such diversified data, even smaller one, आपका ripen mango, आपका rotten mango, कच्चा mango, they all can be inputted inside the algorithm, but wrong data you are supposed to remove. Right,
Okay.
Darpan? Okay. Any other question? Okay, so lot many data is needed. Now, second important thing is a feature. Now, हम लोगों ने see try to understand one thing. जैसे मैंने आपको मेरा एग्जांपल बताया कि what I am getting the daily stock price of the particular share, particular stock. पिछले 10 साल का ये मुझे मिल रहा है. Now, I cannot put that data directly to my algorithm. मुझे क्या करना पड़ेगा, मुझे उसके बेस पे अपने फीचर्स कैलकुलेट करने पड़ेंगे. So for example, there is a feature called 52 week moving, 52 week highest value, 52 week lowest value, 20 days moving average, 50 days moving average, RSI, ये अलग अलग फीचर हैं. So वो डेटा के बेस पे I am going to calculate the features. तो आपका डेटा डायरेक्टली आप नहीं रख सकते. इन आवर केस, ये जो हमारा फ्रूट वाला एग्जांपल जो आपको ज्यादा अच्छी तरह से समझ में आएगा, तो फॉर एग्जांपल मेरे जो 100 इमेजेस है, वो 100 इमेजेस को मुझे क्या करना पड़ेगा, आई नीड टू एक्सट्रैक्ट द फीचर्स. नो, फीचर्स क्या हो सकते हैं? नंबर वन, व्हाट इज द हिस्टोग्राम ऑफ द इमेज. फॉर एग्जांपल मैंने एक इमेज बन ली हुई है, वो इमेज में येलो कलर के पिक्सल कितने हैं, ग्रीन कलर के पिक्सल कितने हैं, रेड कलर के पिक्सल कितने हैं, ब्लैक कलर के पिक्सल कितने हैं, व्हाइट कलर के पिक्सल कितने हैं. ये मेरा एक फीचर हुआ. नंबर टू, फॉर एग्जांपल जो मेरा ऑब्जेक्ट अंदर है वो सर्कल है या वो रेक्टेंगल है या वो क्या है, वो मेरा एक और फीचर हुआ. मेरा जो भी ऑब्जेक्ट है वो ऑब्जेक्ट की साइज कितनी है, वो मेरा एक और फीचर हुआ. ऐसे बहुत सारे फीचर्स हो सकते हैं. तो एक इमेज के अंदर से यू आर ट्राइंग टू जनरेट लॉट मेनी फीचर्स. and this feature you will give to the input as an input to the algorithm. So you need to calculate the, you need to get the feature. In fact, there is something called feature engineering as well. एक बात ध्यान रखना, इट मे बी पॉसिबल कि मैं आपकी क्लास में सेम डेटा पास करूं, सेम डेटा दूं, और मैं आपको बोलूं कि सेम एल्गोरिथम इस्तेमाल करो, बट देन ऑल्सो आप सबकी एक्यूरेसी अलग अलग आए. इट इज क्वाइट पॉसिबल एंड द रीजन इज वेरी सिंपल, बिकॉज फीचर जो एक्सट्रैक्शन है वो आपके हाथ में है. आप कौन से फीचर एक्सट्रैक्ट करते हैं, आप वो कैसे उनको कितने फीचर्स लेते हैं, हाउ डाइवर्सिफाइड दे आर, इन सब के ऊपर डिपेंड होगा आपका actually result of the algorithm. And that is the reason feature extraction is very important and proper effort has to be placed in the feature extraction. So if suppose I इसमें example दिया हुआ है कि from the name, if I want to identify that whether the particular name is a name of a boy or the girl, मुझे find out करना है. So feature can be कि वो वाले नाम के अंदर vowel कितने हैं. सो नॉर्मली जो गर्ल्स के नाम होते हैं उसमें वॉवेल ज्यादा होते हैं. फॉर एग्जाम्पल आपका जो नाम है वो वॉवेल से शुरू हो रहा है, वॉवेल से खत्म हो रहा है, और आप ऑब्जर्व करोगे कि नॉर्मली जो वॉवेल से खत्म होने वाले नाम हैं वो गर्ल्स के ज्यादा होते हैं. सो दिस इज अ फीचर. नाउ यू नीड टू, ना ये मैंने तो आपको नाम दे दिए, नेम इज माई डेटा, उसमें से फीचर निकालना आपका काम है. So this feature you need to get from each and every data. आपको सभी डेटा में से वो फीचर को लेके आना पड़ेगा, एंड जितने अच्छे फीचर्स होंगे आपका उतना अच्छा एल्गोरिथम होगा. So this is about the feature. Now everyone is able to relate how data and feature are related, or any query left out?
Sir, why everything is on data?
Why everything is on data means?
Sir, like you told that for ML we have to collect the data, we have to take the features, and we have to work, we have to train the algorithm on that basis. So why it is on the data? Why can't we go in any other way to get an actual output instead of getting a predicted output?
Yeah, Darpan, this is precisely what we have seen, that there are two different approaches. These two approaches. In one of the approach, you will give a program. So you will get a data, you will give a data, you will give a program, and the computer will give the output. But here we will give a data and they will get a program. Now to get a program you have to give the data ना. अगर आप डेटा नहीं दोगे तो आपको प्रोग्राम कहाँ से मिलेगा?
Okay, got it, sir.
So in the machine learning entire approach is like this only. Here you need not to program for the particular data. The computer itself will program itself. Any other question? Okay. Now सबसे मशीन लर्निंग का जो हार्ट है, सबसे इंपॉर्टेंट है, वो मॉडल है. Now this model is basically algorithm. हम लोग कई बार इसको algorithm भी बोलते हैं. For which algorithm you are using, it is all about the model. There are some very good machine learning algorithms like your neural network, like forward vector machine, KNN. I will not say कि particular algorithm is better than any other, because depending on the problem, ये algorithm भी अलग-अलग behave करते हैं. For the particular problem, ANN will be better. For the another data, ANN will fail miserably. So कौन सा algorithm आप इस्तेमाल कर रहे हो, that is about the modeling. So हमने पहले देखा डेटा में से फीचर एक्सट्रैक्ट किए, वो फीचर को हम लोगों ने मॉडल में डाला. Now and the last will be the evaluation. अब जो मॉडल आपका डेवलप हुआ है, whether that model is right or not, तो उसके बहुत सारे अलग अलग पैरामीटर्स हैं. देयर इज समथिंग कॉल्ड एक्यूरेसी. सो एक्यूरेसी इज ऑल अबाउट कि आपने जो भी ऑब्जर्वेशन आप लोगों ने लिए, वो ऑब्जर्वेशन में से आपने कितने आपके पास सही ऑब्जर्वेशन थे और उसमें से आपने कितने सही प्रिडिक्ट किए. तो इट इज ऑल अबाउट द एक्यूरेसी. सिमिलरली देयर इज समथिंग कॉल्ड प्रिसिजन एज वेल, रिकॉल एज वेल, स्टैंडर्ड एरर. ये सारे अलग अलग पैरामीटर्स हैं. हम लोग जो यूज करते हैं नॉर्मली, जो मोस्ट ज्यादा प्रिफर्ड हैं, One is accuracy, then there is a precision, there is a recall, and there is something called F1 score. F1 स्कोर इसलिए कंसीडर होता है क्योंकि F1 स्कोर के अंदर ऊपर के तीनों तीन आ जाते हैं. यू टॉक अबाउट एक्यूरेसी, प्रिसीजन, रिकॉल, तीनों तीन कहीं ना कहीं आपके F1 स्कोर के अंदर आ जाते हैं. बट यू कैन यूज एनी ऑफ दिस evaluation metrics to get the output of the to understand how much your algorithm is accurate or not. Ideally इन सब की वैल्यू एक बराबर होनी चाहिए. आइडियली इन सब की वैल्यू 0.95 के ऊपर होनी चाहिए. अगर नहीं है तो आपको अपने एल्गोरिथम में थोड़ा सा चेंज करना पड़ेगा, ट्रेन करना पड़ेगा. ओके, देन देयर इज समथिंग कॉल्ड रिग्रेशन, और इसके बारे में हम ऑलरेडी देख चुके हैं. तो रिग्रेशन सर्चेस फॉर द रिलेशनशिप अमंग द वेरिएबल्स. तो फॉर एग्जांपल सैलरी, फॉर एग्जांपल आप किसी कंपनी के हायरिंग डिपार्टमेंट में हैं और आप कोई भी नए एम्प्लॉय को सैलरी ऑफर कर रहे हो. आपकी कंपनी बहुत बड़ी है, आपकी कंपनी में मल्टी सिटी लोकेटेड है, बड़ौदा है, न्यूयॉर्क है, दिल्ली है, बेंगलोर है, सब जगह पे है. सो आप उसको किस वे पे, आप उसको किस बेस पे सैलरी ऑफर करोगे, उसके क्या क्या पैरामीटर्स होने चाहिए. सो एक्सपीरियंस कैन बी वन पैरामीटर, कि कितने साल उसने काम किया है, उसका एजुकेशन क्या है, व्हाट विल बी हिज और हर रोल, कौन सी सिटी में उसको काम करना है. ये सारे क्या हो गए, फीचर्स हो गए. सी फॉर एग्जांपल उसी मैनेजर को जिसको आप बड़ौदा में आप 50,000 दे रहे हो, उसको बॉम्बे में 50,000 आप नहीं दे सकते हो, क्योंकि बॉम्बे का जो लिविंग स्टैंडर्ड है अलग है, हाई है, और वहां पे आपको उसी मैनेजर को 70-80,000 देना पड़ेगा. सो हियर you are trying to predict the salary. Now salary is what? It is a number, it's a value. So regression is always hunting for that particular number, value only. That here you will be having a dependent features, you will be having a independent features, and आपके जो dependent features हैं वो आपके output हैं, और independent features क्या होंगे, वो आपके input होंगे. In our case हमने salary वाला जो example लिया, उसमें आपका dependent feature क्या हुआ, सैलरी हुआ, और आपके इंडिपेंडेंट फीचर्स कौन कौन से हुए, एक्सपीरियंस हुआ, लेवल ऑफ एजुकेशन हुआ, रोल हुआ. ये सारे आपके इंडिपेंडेंट फीचर्स हो गए. बेस ये इंडिपेंडेंट फीचर्स के ऊपर ही आप क्या करोगे, यू आर गोइंग टू कैलकुलेट द, और यू आर गोइंग टू ट्रेन द मॉडल टू फाइंड द वैल्यू ऑफ द डिपेंडेंट वेरिएबल. नाउ आउटपुट इज नॉर्मली मेंशन बाय वाई. आपका जो आउटपुट होगा आप नॉर्मली इसको वाई से मेंशन करोगे, और इनपुट हमेशा आप एक्स से करोगे. बट बिकॉज यहाँ पे आपके मल्टीपल फीचर्स होते हैं, आप क्या करोगे, x1, x2, x3, x4 करके जितने फीचर्स होंगे सारे के सारे, दे ऑल विल बी वन इनपुट. देन देयर इज वन मोर x1, x2, x3, देयर इज वन मोर x1, x2, x3 एंड सो ऑन. तो व्हाट डज दिस रिग्रेशन इज डूइंग? रिग्रेशन करता क्या है? नाउ रिग्रेशन, सो फॉर एग्जांपल इफ सपोज दिस आर माय ऑब्जर्वेशंस, ये मेरे ऑब्जर्वेशंस हैं. तो ये ऑब्जर्वेशन, ये मेरा इनपुट है, -10, 10, 20, 30, और उसका अप्रोप्रिएट ये मेरा आउटपुट है. ये मेरे ऑब्जर्वेशन है सारे. तो फॉर एग्जांपल फॉर दिस पर्टिकुलर इनपुट my output is -19. For example, this particular observation, my output is -12. For this particular observation, my output is +40. So I've plotted everything on the graph, and I will try to find a line, a linear line which will minimize the error among all this. So this is what regression is doing. Now in this example, if you will see, अब देखो यहाँ पे ऑब्जर्वेशंस आर नॉट लीनियर. आप अगर प्लॉट करके इनको देखोगे तो दे आर नॉन लीनियर. सो इसके लिए मुझे क्या करना पड़ेगा, आई नीड टू गो फॉर द नॉन लीनियर अप्रोच. सो you have a linear approach, you have a non-linear approach. Apart from that, you have a single variable approach and multiple variable approach as well. And एक बात ध्यान रखना, अगर आपका सिंगल वेरिएबल अप्रोच है, आपको मशीन लर्निंग में जानने की कोई जरूरत नहीं है, आप आसानी से उसकी बिनाई कर सकते हो. मशीन लर्निंग का काम 40-50 फीचर्स हैं. आपके 40-50 फीचर्स हैं, जिसमें मल्टीपल इंडिपेंडेंट वेरिएबल, इसके ऊपर से आप एक पर्टिकुलर आउटपुट को प्रेडिक्ट कर रहे हो. सो Normally in machine learning, we will be focusing on the your multiple variables only. Linear, non-linear, it will depend on the type of the problem. जो मेजर algorithm हम लोग यूज करते हैं for regression will be linear regression is one algorithm, non-linear regression, naive Bayes is one more algorithm. सपोर्ट वेक्टर मशीन का एक वेरिएंट है, सपोर्ट वेक्टर रिग्रेसर, that is algorithm for the regression as well. So in the regression, how we are getting the value? Because you have plotted something. For example, अगर मैं बोलूं कि यहाँ के ऑब्जर्वेशन के लिए मुझे क्या वैल्यू मिलेगी, तो आप क्या करोगे, ये लाइन को एक्सटेंड कर दोगे और यहाँ पे जो भी वैल्यू आ रही है आप वो वैल्यू मुझे देख के यहाँ से रिटर्न करोगे. तो दैट इज द रीजन रिग्रेशन के अंदर, जैसे यहाँ पे देखो रिग्रेशन के अंदर यहाँ भी आपको कोई ना कोई एक वैल्यू मिलेगी. सो दिस इज अबाउट हाउ द ट्रेनिंग हैपेंस इन द regression type of the problem. Any question about this? This is very important ना, क्योंकि ये जो हम पढ़ रहे हैं अभी रिग्रेशन है, क्लासिफिकेशन है, आप लोग इनको मेजोरिटी इस्तेमाल करने वाले हो. Okay, next category will be classification, and it is different than regression in a way that you are not going to get any particular value. Here you are trying to predict that it will fall under which particular class. So classification specifies the class to which data elements belong to and is best used when the output is a finite and the discrete value. It predicts a class for an input variable as well as the output. So यहाँ पे आपका जो भी input होगा उसके लिए वो appropriate output class को identify करेगा. इसमें दो अलग अलग कैटेगरी है, एक आपका टू क्लास क्लासिफिकेशन है, एक आपका मल्टी क्लास क्लासिफिकेशन है. नाउ इन द टू क्लास क्लासिफिकेशन हमने जैसे एग्जांपल देखा था कि वेदर स्टूडेंट विल बी पास और फेल, इसमें दो ही क्लास हैं, आइदर पास होगा या फेल होगा, ट्रू होगा या फॉल्स होगा. जैसे इन माय केस whether this is a good stock to purchase or not good stock to purchase, so there is only two classes. मल्टी क्लास क्लासिफिकेशन में आपके मल्टीपल क्लासेस होंगे. हमारा जैसे फ्रूट वाला एग्जांपल था, द फ्रूट कैन बी योर मैंगो, इट कैन बी बनाना और इट कैन बी एप्पल. सो इट इज अ मल्टी क्लास क्लासिफिकेशन. तो आप डिपेंडिंग ऑन द इनपुट आप क्या करोगे, आप इसको मल्टीपल क्लासेस के अंदर यू विल ट्राई टू फिट के कौन से क्लास में ये प्रॉपर्ली फिट हो रहा है. ना एग्जांपल्स क्या होंगे इसके, आप चेक कर सकते हो वेदर द पर्टिकुलर ईमेल इज अ स्पैम ईमेल और नॉट. ना आप लोग को पता होगा आपके ईमेल में बहुत सारे ईमेल्स ऑटोमेटिकली स्पैम में चले जाते हैं, स्पैमिंग में चले जाते हैं. तो वो क्यों चले जाते हैं, क्योंकि देयर इज अ मशीन लर्निंग एल्गोरिथम वर्किंग जो चेक करता है कि वो स्पैम है कि नहीं है. ना कैसे चेक करेगा, वो बहुत सारे कीवर्ड्स हैं, जैसे प्रमोशन करके कीवर्ड आया, लॉटरी करके कीवर्ड आया, जब भी ऐसे वर्ड आएंगे ना वो ऑटोमेटिकली स्पैम में चला जाएगा. कई बार इस चक्कर में आपके सही वाले ईमेल भी चले जाते हैं, बट देन इज फाइन. देन टू आइडेंटिफाई द कस्टमर सेगमेंट. नो कस्टमर प्रोफाइलिंग करके कॉन्सेप्ट है, जो जिन लोगों ने मार्केटिंग पढ़ा था अभी आईडी कोर्स, स्वयं कोर्स में उनको पता होगा. कस्टमर प्रोफाइलिंग करके कॉन्सेप्ट है जिसमें आप कस्टमर को अलग अलग कैटेगरी में आप उनको अलग अलग सेगमेंट्स में क्लासिफाई करते हो. तो बेस्ड ऑन द बिहेवियर, मतलब जैसे कोई कस्टमर बार बार डिफॉल्ट कर रहा है, वो क्रेडिट कार्ड का पेमेंट नहीं कर रहा है, तो आप क्या करोगे, उसको पर्टिकुलर कैटेगरी में डाल दोगे. अगर कोई कस्टमर ऑनलाइन ज्यादा बाई कर रहा है तो आप उसको पर्टिकुलर कैटेगरी में डाल दोगे. सो इस तरह कस्टमर को अलग अलग सेगमेंट में डिवाइड करने के लिए भी आप क्या करते हो, यू आर यूजिंग दिस क्लासिफिकेशन टू फाइंड इफ द बैंक लोन इज ग्रांटेड और नॉट. सो मतलब आपको चेक करना हो कि ये बंदा बैंक का लोन रीपे कर पाएगा कि नहीं कर पाएगा. यू कैन यूज दिस क्लासिफिकेशन अप्रोच. आउटपुट विल बी यस या नो, पे कर पाएगा या नहीं कर पाएगा. टू आइडेंटिफाई इफ अ किड विल पास और द फेल इन द एग्जामिनेशन. हमने अभी एग्जांपल जो शुरुआत में देखा था, द सेम एग्जांपल. So this is a very brief introduction about the classification, and here you will see कि for example I have a apple, I have a guava. So जो भी एप्पल के ऑब्जर्वेशन है वो मेरे सारे यहाँ पे ऊपर आ रहे हैं, गुआवा के ऑब्जर्वेशन मेरे सारे यहाँ पे आ रहे हैं, एंड देन आई एम ट्राइंग टू ड्रॉ लाइन बिटवीन दिस टू. तो इसके ऊपर जो भी आएंगे सारे एप्पल होंगे, उसके नीचे जो भी आएंगे सारे के सारे मेरे गुआवा होंगे. नाउ दिस इज वन मोर एग्जांपल जहाँ पे आप क्या कर रहे हो, यू आर ट्राइंग, यू हैव आपके पास एक जो फ्लावरिंग प्लांट है उसकी पेटल है, तो उसकी लेंथ है और उसकी विड्थ है, दोनों आपके पास हैं। तो आप क्या कर रहे हो, आप उसकी लेंथ और विड्थ को आप मैप कर रहे हो। तो आप देखो यहाँ पे ये पूरा क्लस्टर बना, मतलब ये क्लस्टर का मतलब क्या हुआ कि ये पर्टिकुलर टाइप के फ्लावर के ही पेटल है। सिमिलरली आपका एक और यहाँ पे क्लस्टर बना, फिर आपका एक और यहाँ पे क्लस्टर बना। सो हियर ये आपका वो मल्टी क्लास वाला एग्जांपल आ गया, जिसके बेस से आप आइडेंटिफाई कर सकते हो कि वेदर द पर्टिकुलर ऑब्जर्वेशन इज योर 0, 1 और 2, कौन सा वाला ऑब्जर्वेशन है। तो हियर इफ यू विल क्लोजली नोटिस कि आपने भले इसको पार्टीशन कर दिया, डिवाइड कर दिया, बट देयर आर सम ऑब्जर्वेशन जो ये रूल को फॉलो नहीं कर रहे, वो चेंज हो रहे हैं, बाहर आ रहे हैं, ये रहेगा। एंड दैट इज द रीजन कि आपको कभी भी 100% एक्यूरेसी से कोई भी रिजल्ट नहीं मिल पाता है, आपको थोड़ा बहुत वेरिएशन तो झेलना ही पड़ेगा। तो मेजर एल्गोरिथम क्लासिफिकेशन में आते हैं, वो है आपके लॉजिस्टिक रिग्रेशन। वहां पे लीनियर रिग्रेशन था, यहाँ पे लॉजिस्टिक रिग्रेशन आया। सपोर्ट वेक्टर मशीन, KNN बोलते हैं हम इसको, डिसीजन ट्री एंड द रैंडम फॉरेस्ट। So any question about the classification thing?
So can we have one or two algorithms together in one?
Excellent, very good question दर्पण। जैसा कि मैंने शुरुआत में बोला, पर्टिकुलर एल्गोरिथम विल बी बेस्ट सुटेबल, ऐसा हो ही नहीं सकता। In machine learning there is an approach called ensemble approach. Now what does this ensemble approach will do? Ensemble approach will combine multiple algorithms, और ये मल्टीपल algorithms में से जो बेस्ट रिजल्ट होगा वो बेस्ट रिजल्ट वो एज आउटपुट में लेगा। So that is an ensemble approach.
Okay.
Okay, any other question?
Sir, तो इंडस्ट्री में अभी which standard is followed? Like basically algorithms are merged together on for one data, or it's like a single algorithms for single type of data?
दर्पण, इसका है ना कोई थंब रूल नहीं है। मतलब मैंने जो इंडस्ट्री में जो देखा है वो सपोर्ट वेक्टर मशीन ज्यादा इस्तेमाल होता है, बट नाउ अ डेज एनसेम्बल अप्रोच बहुत ज्यादा इस्तेमाल हो रहा है। इनफैक्ट मेरे पीएचडी का टॉपिक भी एनसेम्बल अप्रोच ही है, जिसके अंदर आई एम गोइंग टू यूज मल्टीपल एल्गोरिथम्स लाइक सपोर्ट वेक्टर मशीन, आर्टिफिशियल न्यूरल नेटवर्क एंड दिस KNN। ये 3 एल्गोरिथम पे मैं काम करने वाला हूँ। बट हर चीज का एडवांटेज होता है, डिसएडवांटेज होता है। एनसेम्बल अप्रोच का मतलब ये है कि आप मल्टीपल एल्गोरिथम्स को एक साथ रन कर रहे हो। तो अगर यहाँ पे एक एल्गोरिथम को रन करने में इतना कंप्यूटेशन पावर लगता है, तो मल्टीपल एल्गोरिथम्स को रन करने में कितना कंप्यूटेशन पावर लगेगा। सो एडवांटेजेस डिसएडवांटेजेस दोनों साइड पे।
Okay.
एनी अदर क्वेश्चन? ओके, जैसा मैंने आपको बताया, आप जब भी कोई भी डेटा सेट लोगे उसका आप 80% को आप ट्रेनिंग में इस्तेमाल करोगे और 20% को आप इवैल्यूएशन टेस्टिंग में इस्तेमाल करोगे। ये 80% में से भी 60% एक्चुअली ट्रेनिंग के लिए इस्तेमाल होगा और 20% क्रॉस वैलिडेशन के लिए इस्तेमाल होगा। नाउ मैं एक टास्क आप लोग के लिए छोड़ के जा रहा हूं, और वो है ये वर्ड क्रॉस वैलिडेशन। आप लोग प्लीज नोट डाउन कर लो। कल हमारा जब सेशन शुरू होगा, पहले 10 मिनट में आपके क्वेश्चंस का आंसर दूंगा, और वो 10 मिनट में ही मैं आपसे ये भी पूछूंगा कि ये क्रॉस वैलिडेशन होता क्या है, राइट। सो दिस इज हाउ द डेटा इज डिवाइडेड। नाउ यू कैन हैव योर ओन, मतलब कुछ लोग 75 ट्रेनिंग में लेते हैं, 25 टेस्टिंग में लेते हैं, कुछ लोग 90 ट्रेनिंग में लेते हैं, 10 को ट्रेनिंग में लेते हैं, बट नॉर्मली हम लोग 80-20 का रूल फॉलो करते हैं। तो ये एक मशीन लर्निंग का एक पूरा कियोटिक डायग्राम है। नाउ आप अगर इसको ध्यान से देखो तो हम इसको एक जगह से शुरू करते हैं, सेंटर से शुरू करते हैं, मशीन लर्निंग से ऊपर जाते हैं। आप देखो क्लासिकल लर्निंग है, क्लासिकल लर्निंग के अंदर ये सुपरवाइज, ये अनसुपरवाइज। सुपरवाइज की हमने कैटेगरीज देखी थी अभी, रेग्रेशन और क्लासिफिकेशन। नाउ अनसुपरवाइज की कैटेगरी होगी आपकी क्लस्टरिंग एंड पैटर्न सर्च, विच इज एसोसिएशन बेसिकली, जो हमने वहां पे देखा था। एंड डायमेंशनलिटी रिडक्शन इज एक्चुअली नॉट द सॉल्यूशन ओरिएंटेड एल्गोरिथम, इट इज अप्रोच टू रिड्यूस द डायमेंशन। तो इसका आउटपुट आपको नहीं मिलेगा। इसका आउटपुट लेने के लिए मतलब जो प्री प्रोसेसिंग हम बोलते हैं ना, दैट इज द डायमेंशनलिटी रिडक्शन। कई बार आपके बहुत सारे डायमेंशन होंगे, उनको कम करने के लिए आपको ये जैसे पीसीए सब पार्टिकल कंपोनेंट ऑप्टिव एनालाइजर ये सबसे बेस्ट माना जाता है। ये करने के बाद भी आपको इसका जो आउटपुट आएगा वो इनपुट में देना पड़ेगा आपके पैटर्न सर्च में या तो क्लस्टरिंग में, बट दिस इज नॉट अ सेपरेट एल्गोरिथम। फिर मशीन लर्निंग की एक टाइप है रीइंफोर्समेंट लर्निंग, हमने देखा था, जिसमें क्यू लर्निंग आपका या एम के डी एक अलग कॉन्सेप्ट है। जैसे दर्पण ने क्वेश्चन पूछा एनसेम्बल अप्रोच, जिसके अंदर आइदर आप स्टैकिंग इस्तेमाल कर सकते हो, बैगिंग इस्तेमाल कर सकते हो, बूस्टिंग इस्तेमाल कर सकते हो। दिस आर द टेक्निक्स। एनसेम्बल की अलग अलग वे हैं कैसे आप इसको वो एल्गोरिथम को मर्ज करना चाहते हो। जैसे फॉर एग्जांपल वन अप्रोच इज दैट टेक द बेस्ट वन, वन अप्रोच इज दैट टेक द एवरेज अप्रोच, एवरेज एक्यूरेसी। सो कौन सा आप ले रहे हो, इट डिपेंड्स ऑन दिस थ्री थिंग्स, स्टैकिंग, बैगिंग एंड बूस्टिंग। नाउ मशीन लर्निंग में से डिवाइड हुआ आपका न्यूरल नेटवर्क एंड डीप लर्निंग, जिसके अंदर आपका सीएनएन आएगा, एलएफटीएम आएगा, जीआरयू, जीएएन, एनकोडर डिकोडर आएगा एंड परसेप्ट्रॉन आएगा। सो ये एक समरी है, हमने जो भी अभी तक देखा या जो भी हमने नहीं देखा या देखने वाले हैं उसकी समरी है ये, राइट? So I'm done with my session for the day. I know थोड़ा theoretical था ये, and मेरी साइड से I tried to explain you with as many examples as possible. Still अगर अभी किसी के माइंड में कोई क्वेश्चन आ रहा है तो you are free to ask me. कल तो आपको क्वेश्चन लेके आने ही है, इसके बेस पे आप स्टडी करोगे और आप और क्वेश्चन लेके आओगे, बट अभी टाइम भी कोई क्वेश्चन आ रहा हो तो प्लीज शेयर विथ मी।
So machine learning is basically we are learning machine or machine is learning on itself.
Yeah, second one, machine is learning on itself by the data provided by you.
Okay.
ओके, एनी क्वेश्चन? कल का सेशन बहुत इंपॉर्टेंट होगा। कल हम लोग इसमें से एक एल्गोरिथम सपोर्ट वेक्टर मशीन उसको लेने वाले हैं, कैसे काम करता है, क्या काम करता है, पूरा समझने वाले हैं। एंड मोस्ट इंपॉर्टेंटली सपोर्ट वेक्टर मशीन को इंप्लीमेंट करके देखने वाले हैं ऑन अ लोकल सिस्टम एज वेल एज ऑन द गूगल कोलैब। गूगल का एक प्लेटफॉर्म है कोलैब, जिसमें आप मशीन लर्निंग एल्गोरिथम्स रन कर सकते हो, क्योंकि वहाँ पे कंप्यूटेशन पावर आपको ज़्यादा मिलता है। तो दोनों चीज़ें हम करने वाले हैं। कल का सेशन बहुत इंपॉर्टेंट इसलिए रहेगा कि आपको पता चलेगा कि कौन कौन सी लाइब्रेरीज इंपॉर्टेंट हैं आपके मशीन लर्निंग को रन करने के लिए। कल के सेशन के लिए एक रिक्वेस्ट रहेगी, सब लोग लैपटॉप पे बैठेंगे और इंटरनेट कनेक्शन अच्छा ऑन रखेंगे, क्योंकि कुछ चीज़ें मैं आपको इंस्टॉल करूँगा, कुछ लाइब्रेरीज में आपसे इंस्टॉल करवाऊँगा एट दैट टाइम ओनली। वो आपको उस टाइम पे इंस्टॉल करनी होगी। कोड मैं आपको शेयर कर दूंगा थोड़ा सा पहले एडवांस में, एंड सो दैट आप लोग अपने पास रखें, आप इसको सीधा रन करके अपने वहीं पे देख सकते हैं। डन? सो ओके विद टुडे सेशन, शैल बी स्टॉप नाउ? प्रियंका?
Yes, sir. We can stop
Yes,
and we
sir.
can continue later.
सर सॉरी
या
सर
या
सर हम इंस्टॉल किस में करेंगे, आई मीन कोडिंग किस में करने वाले हैं?
आई वुड प्रिफर जुपिटर, लेकिन अगर जुपिटर नहीं भी है तो भी चलेगा। देखो हम लोग जब कोलैब में जाएंगे ना, तो कोलैब में तो जुपिटर ही है, लेकिन अगर जुपिटर नहीं है, अगर आपका आईएलडी है या फिर आपका कोई थर्ड पार्टी एडिटर है ना, डोंट वरी, उसकी चिंता मत
नो
करना।
सर, आई एम यूजिंग जुपिटर, दैट्स व्हाई आई वाज आस्किंग।
या वी विल बी डूइंग ऑन जुपिटर ओनली।
ओके सर, नो प्रॉब्लम, थैंक यू सर।
ओके, एनी अदर क्वेश्चन? ओके, सो दर्पण, चलो बाय एवरीवन एंड सी यू टुमारो एट द सेम टाइम। कल प्रैक्टिकल होगा, तो कल आई एम श्योर कल आपको ज़्यादा मजा आएगा। एंड आज के कोई भी डाउट होते हैं, प्लीज़ फील फ्री, टुमारो विल डिस्कस एंड देन विल मूव फॉरवर्ड। आई एम कंप्लीटिंग एट 11:30।